Hi, in this bit I'm going to cover both the Cartesian equation of a plane in general form and an example in one video, okay? Because Cartesian equation is actually a lot easier to get your head around, it's a lot easier to understand, okay? Like with most things, Cartesian coordinates usually easier than vector coordinate system, okay? Right, so the Cartesian equation of a plane is this: ax plus by plus cz equals d. Remember, no vectors because it's a Cartesian form, okay? Now, just take a moment to think about that, okay? This is your general equation of a straight line, of course, in Cartesian form. With a straight line, you only have two different variables, don't you? The x and y, obviously, because it gives you just a straight line. But when you've got a plane, you need three variables. Okay, if you think about that, it makes logical sense. Two variables to give you a straight line, three variables to give you a plane, okay? You need a constant in there as well, okay? And that's your constant there, okay? So here you've got, this, you interpret that as the gradient. Well, there's no real method there for the steepness of the actual plane in terms of the actual equation, okay? But you've got some variable in terms of x, so some number times x, like 2x, 3x, negative 5x. You've got some variable in terms of y, some variable in terms of z, with the a, b and c, those are just coefficients, and there's your constant, which sometimes you see on the left-hand side, and you get equals 0. I prefer it like that, on the right-hand side, equals d. So that's your Cartesian equation of a plane. Pretty simple, isn't it, okay? But here is a wonderful, brilliant, and fantastic, I can't say enough words for this, okay, fact about this Cartesian equation, okay? If you take the letters A, B, C and write it as a vector, okay, you're probably thinking, hang on, you said this is Cartesian, why are you putting vectors in it? Because it's showing you the relationship between vectors and the Cartesian plane. If you take those coefficients A, B, C and write it as vector A, B, C, that A, B, C is a normal vector to the plane. Have I mentioned the word normal before? Yeah, you know what the word normal is. It means perpendicular, like the equation for tangent is, parallel to, no. Yeah, you know what I mean. The normal is perpendicular to a tangent, okay? Yeah. So ABC is normal to the plane. Okay, so you've got a plane, here it is, right there, maybe, that's the plane, okay? And you've got the equation, so the ABC, as a vector, that is going to be perpendicular, okay? And remember, there's an infinite number of those that can be perpendicular to this, okay? It's perpendicular to that plane. If I just put it sideways like that, then of course you've got perpendicular, which is pretty amazing, really. So there's no proof of that. If I proved every single one of these results, I'll be here forever. But that's what university maths is like, really. That's sometimes why the course is so long, because you've got to prove absolutely everything. Okay, so ABC is normal to the plane, which is great. Okay, and that is basically how we're going to answer this question. Now, this is exactly the same question as when we did the vector equation. All I've done is I've written the word Cartesian after René Descartes, of course. Cartesian equation of a plane, find a Cartesian equation as opposed to a vector equation of a plane that passes through, and I've got the same points that I had earlier. Okay. Now, what are we going to do for that? The answer is, so I've not given you much time to think about it, okay, because I'm going to tell you, you can find what a normal to the plane is, okay. So here are your 3 points. Let's just call this the plane, okay. So that's point A, for example, point B, point C there, okay. All lie in this plane. Notice we want to find a vector that is perpendicular, normal to those 3. How do we do it? We use the vector cross product, okay? Because if you can find a vector that's perpendicular to both those 2 there, AB and AC, if you find a vector that's perpendicular to those 2, they've got to be perpendicular to the plane. Isn't that wonderful? So that's why I introduced the cross product to you, so you could do the plane stuff, okay? All right, because it's needed for this. So what we need to do is first of all look at what AB and what AC are. Right? Make sure you've got a note of that, because it's very, very important and lovely. Okay. It's my favourite fact about the equation of the plane, actually. Not that there are many other facts, but there you go. So AB, you've got to work out that is. So that to that. Oh, I did that in the other video, didn't I? But I forgot what it was. So that's 1, 0, 0. Oh yeah, that kind of things about that, AB. And I did AC, so let's be consistent, okay? So what did I have for that? I had 2, 1, 6, yeah? So that 2, 1, yeah, 6. always double check those, because you know that's the first bit. If you get any of those numbers wrong, so easy to do. Any of those numbers wrong and messes up the whole question. Okay. Between you and me, I actually did that on one of the videos a while ago. Okay. The very start, I kind of messed up one of the numbers. I got to the end of the 20-minute video, or however long it was, and then I sort of looked at the answer and I thought, oh my God, I had to do the whole video again and pretend I was doing it for the first time. So from personal experience, it's very simple to do. Okay, I'm going to check it again. So 2, so 1. Yeah. It wasn't this one, by the way. It was, I think it was yesterday. It was definitely yesterday at some point. Okay. Alright, so we've got A, B, and AC. So in context, all right, we've got that and we've got that. Now we need to find a vector that's perpendicular to both of those. So we need to do the cross product between them. Okay. So notation-wise, you could write it as AB cross AC, just to show that we're doing the cross product. Okay. Or if you want, you write it like this: 1, 0, 0 cross with 2, 1, 6. Okay. And then that's when you get the determinant out and work out this. So either you pause the video and do it yourself, go back to your notes again, or you just go along with me, I don't know. So here's your determinant, so I, J, K, and then 1, 0, 0, what is that? 1, 0, 0, 2, 1, 6, 2, 1, 6, okay, there we go. And then we just do that. So we've got I multiplied by, and that's going to be 0, 0, 1, 6. By the way, this is so easy to make a mistake with as well, okay. So just, you know, you can see I'm doing it in my head there, just 0, 0, 1, 6. Okay, and then subtract J, and then what we're going to have 1, 0, 2, 6. Let's just check that. Yeah, 1, 0, 2, 6. Okay, and then plus K. Remember the positive, negative, positive. Okay, and then you've got 1, 0, 2, 1. Yeah, and then I'm kind of writing my answer at the bottom here. So you've got, remember how to do these? So that times that, subtract that times that. So 0, subtract 0. Oh, it's kind of simple, isn't it? Okay. So I'll just put it as 0i. Looks like I write it oi, doesn't it? Oi! Yeah. That's a British thing, isn't it? I've just sort of realised that, okay? When you say oi to someone, that's typically British, okay, isn't it really? It's oi, mate! Yeah, you don't hear Americans say that, do you? Only when they're trying to sound British. Anyway, never mind. Yeah, so whenever I see 0i, I always think that, oi, you know. Anyway, enough of that. So, this is why zeros are nice with vectors and matrices, because it makes the thing easier to calculate, okay? So what did I have that as? 1, 6, 2. So that's 6 subtract 0, so that's negative 6j. And then this is 1 subtract 0, so plus k. Right? So what that means is that that cross that is equal to 0, negative 6, 1. Okay? That's why it's useful to write the 0 sometimes, because when you're putting that in column vector form, you've got the 3 values, 0, negative 6, 1. Okay? So that's that. Okay? So let's just rub this off. We're almost there. We're almost there. So that was the most fundamental part of the work that was needed. Okay, can I just rub this off as well? Don't need that anymore. Okay, so what that means is the ABC is that there, ABC. So that means the equation of plane is, well, that's fascinating, 0x, okay, no, subtract 6y plus z equals d. Of course, you don't need to write the 0x and write the equation. Okay, so 0, negative 6, 1. So I've got that now, okay? That's interesting. I wasn't expecting there to be no x component, but there you go. Now, you might think, well, what do you do with the d? What do you do with the d? Simple, okay? This stands for, well, what would be an x coordinate, a y coordinate, and a z coordinate, and just a constant value. What do you do to work out its constant value? Same as you do in a straight line equation question, okay? You just substitute any of the points in and see what happens, okay? If there are any coordinate points with a 0, use that one because it's easier, but there aren't. So I'm going to use the one where you've got positive values because it's generally easier to substitute positive values in, isn't it? So if I use point C, okay, and I get 3 times negative 6, that's negative 18, plus 5 equals d. So you can see there that d is equal to negative 13. So therefore my equation of the plane is negative 6y plus z equals negative 13. Very suspicious about that, is that correct? Because it's now, you know. Oh, it was not an example in the text, but okay, I just, yeah. Well, yeah, that's got to be it then, isn't it? Okay, I'm fairly confident that I've got it right. Okay. Sometimes you just need verification or validation, don't you? Okay. That's it. That's the Cartesian equation of a plane. I'll give you another one in the next video. Okay. Right, so here's another example. Okay. So find the Cartesian equation of a plane passing through these points. If the points aren't labelled A, B, and C, just sometimes it's useful to label them A, B, C. Okay. And remember, that's the equation that we want to end up with in its general form. All right. So remember the method. Okay. So you either pause the video or work with me. It's totally up to you. Okay. So as a reminder, you need to find a vector that is perpendicular to two other vectors that lie in the plane. All right. So I'll just show you that again. So here's the plane. Okay. Remember, I did say, did you get an answer for that question earlier, by the way? Why it's possible to put any 3 points through a plane. Okay. Well, if you've got any 2 points, any 2 points there and there, you can always put a straight line through any 2 points, can't you? Then you choose a point anywhere else. Doesn't matter where it is. Okay. Just say it's there. Okay. Then what you can do is just create a plane between those 3 points. Okay. Here's another fact arising from that point. If you have any 3 points anywhere in 3-dimensional space, you can join them up into a triangle. That's effectively what I've just done, isn't it? Okay, I've just chosen any 2 points. You can always join them in a straight line. Any third point, you can then join a straight line to both those points, and then they must lie in a plane. Okay, really good, fascinating mathematical facts, aren't they? Anyway, so look, what I'm saying is you've got 3 points that lie in the plane, right there. All you need to do is just find AB and AC, gives you 2 vectors that lie in the plane, and then use the cross product to find the vector that's perpendicular to them, and then it gives you the ABC. It's kind of, you know, it's a straightforward technique. Okay, it's kind of, I prefer the Cartesian equation of a plane, probably because I'm more used to dealing with Cartesian equation stuff. You know, every integral we do, it's always Cartesian based, and every derivative, every graphical base, it's always Cartesian. So it's just, I guess, just what I'm most familiar with. Okay, but the vector equation stuff does have its uses. Right? So AB, what's that going to be? So you're going to have 1, and then 1, and then 1. That's simple, isn't it? 1, 1, 1. And then AC is going to be, what's that going to be? 1, 16, 7. Okay, a bit more awkward, isn't it? Then we do the cross product between those. Okay, so cross product between them. So get the term out. I, J, K. 1, 1, 1, 1, 16, 7. And then the term of that, okay, is equal to I. And then the term of 1, 1, 16, 7 minus J, the term of 1, 1, 1, 7 plus K, the term of 1, 1, 1, 16. God, there's a lot of ones in there, aren't there? Yeah. Let's work it out. So 7 subtract 16, negative 9. Okay. 7 subtract 1 is 6, so it's negative 6. And then 16 subtract 1 is 15. Okay, so that's going to be the normal to the plane. Okay, negative 9, negative 6, J, 15. Okay, now, can I rub this off a bit? I just want to show you a nice little thing here before we go. So you could say, look, negative 9, negative 6, 15, as a vector is normal to the plane. You're probably thinking, what's he doing here? Why isn't he just writing the A, B and C? It's possible you did, I don't know. But what am I going to do? Yeah. Try and work out why this is true. Therefore, 3, 2, negative 5. is normal to the plane. Why is that true? Well, can you see what I've done? I've just divided each of these values by -3. Okay? It's because, isn't it, look, if you take any scalar multiple of that, you don't change the direction, right? So if that's one direction vector, yeah, if you multiply it by any scalar you want, apart from 0, okay, you get the same direction effectively, don't you? Yeah, you're always extending a vector or shortening its length, okay? So sometimes if you get really big numbers, like suppose that was -9 million, -6 million, 15 million, you don't want to be doing millions when you're putting this in, do you? You just divide everything by that same multiple. Okay, so look, that's what I've done, just to make it easy. So look, what I'm going to do is I'm going to write out the general equation as 3x plus 2y, so 3, 2, subtract 5z equals d. Okay, now you might have written -9, -6, 15, okay, but then, you know, guaranteed your value of d would have been a multiple of 3, and you'd be able to divide everything by -3 and get my same answer. Okay, did you do it? I don't know. I don't know. Anyway, so that's what I've gone for. And what I'll do next, substitute any points. I'll use that one because not only does it have a 0, but all the other values are positive as well. You might put that one in. It's up to you. Okay. Of course, you know, it'll work with any of these coordinates that you put in. All right. So maybe I'll check that afterwards. So 3 times 2 is 6 plus 2 equals d. Look how easy that is. D is equal to 8. Okay. I'm not even going to bother rewriting it. I'm just going to put it in there. D equals 8. Let's just check with the others. Okay. So 3 plus 5. Yeah, that's 8. So it works. I've done it with that, so that definitely works. This one here. So that's 6. Oh gosh. Work 6 and plus 32. Subtract 30. So it's 38, 38, yeah, again. Okay, so sometimes, you know, I know I didn't do it in the previous video, maybe I should have done, but sometimes it's worthwhile just checking that all 3 points do lie within the plane. And yeah, they do. So that's it. That's the Cartesian equation of the plane. Yeah, isn't that nice?